Shawnigan Lake, the lake of ancestors, where for centuries and to this day, the first peoples come both to honor and to commune with those who have gone before. We honor and welcome their ancient presence and ask their blessing on the path of learning that lies before us. Again, welcome to Fireside on Sarita. Welcome, friends, to the fourth in this series of firesides on the Book of Existence. And the title of this chapter is Light, Glorious Light. And there is nothing that even approaches light among all of the phenomena of the material universe. Light, in my view at least, holds a preeminent position. It sets its own rules and seems, in a way, to operate outside the rules of time and space that govern the rest of existence, including us. We'll begin just by talking about some of the characteristics of light. And we'll begin with the speed of light. Light travels at just over 186,000 miles per second. And that's such a phenomenal speed that it's very, very difficult for anyone to grasp it. But if you took Route 66 from Chicago to Los Angeles and back, that round trip would be about 4,000 miles. Now, traveling at the speed of light, you could make that round trip 90,000 times in 1 second. And time and distance and the great vastness of space is measured by light. We measure distance in light years, and we measure time in light years. For example, a photon from the center of the Milky Way galaxy takes 40,000 years to reach planet Earth. 40,000 years, and I will say this now, we'll get to this, but relative to planet Earth, it takes that photon 40,000 years to get here. So 40,000 light years, that's the measure. It is 100,000 light years across the Milky Way galaxy. And the next, our neighbor galaxy, Andromeda, is 2.5 million light years away. So it would take us approximately 3 million years at the speed of light, could we travel at the speed of light, to get to Andromeda. Light behaves both like a wave and like particles. Light is a wave, yet it sends out these little packets, these little weightless packets of energy called photons. And these photons travel along at the speed of light relative to our position here on Earth, relative to us, relative to any observer anywhere in the universe, that is. It wouldn't matter where you are, you would still experience light traveling at that speed coming towards you. So light is a wave. It travels at 186,000 miles per second. And it doesn't matter whether it's the faint glow of a burning ember or the flash of a type 1a supernova, which, by the way, is 5 billion times brighter than our sun. Now, the difference in brightness, this is one of the great characteristics of light, has to do with the number of photons that flow across a given space. The brighter the light, the more photons are passing any given point in space. So we're talking about 5 billion times brighter. That means 5 billion times more photons than our sun is giving off at any moment. Light delivers these little packets of energy, and we don't conceive of any end. Once light begins to travel, it continues to travel forever. The waves may stretch out and become invisible. And that brings me to the point that light is both visible, there's the visible spectrum of light, and there's the invisible spectrum of light. Light is the conveyor of knowledge. Everything we know about the great universe in which we find ourselves has been conveyed to us in light. Virtually every fact that we know, everything that we see and measure in the universe, comes to us in light. For instance, and you know, we've all seen a rainbow, and we know that light is refracting through water droplets, and it shatters into its spectrum, from red across the blue spectrum in light. But did you know that that rainbow contains information? Detailed information about the composition of our sun. Because every element burns at its own characteristic color. And we see those colors arrayed in a rainbow. So if we look at the relative widths of those bands of color, we know the relative composition of the sun. We know how much iron, how much hydrogen, how much sulfur. It's written in light. And this, my friends, is true of every sun, every galaxy we observe in the universe. Astronomers collect that light. They create a spectra. They analyze that spectra, and they know exactly the composition of that distant sun. That sun could be hundreds of millions of light years away, yet we know its composition. Light is filled with information, with knowledge. So let's return to those photons that have traveled to us from the center of the galaxy. Now imagine you're looking through a telescope, and you realize, oh my goodness, those photons that are coming through the lens or bouncing off the mirror of my telescope have traveled for 40,000 years to get here to me. And we're going to take a little bit of a side trip here, just for a moment, and we're going to talk about Einstein's theory of special relativity. He published this in 1905. About a decade later, he published his theory of general relativity that had more to do with gravity. But special relativity had to do with light and energy and mass. And what we're talking about here, he's not just talking about relativity, as I mentioned before, that relative to anyone, anywhere in the universe, light would appear to then be traveling at the same speed. We have known about that type of relativity for centuries. However, what Einstein was talking about was the extreme. When we're talking about extreme speeds, what happens to matter when it begins to approach the speed of light. So his theory of special relativity. We know the formula. We've all seen it. E equals mc squared. And c means constant. And that constant is the speed of light in a vacuum. So speed of light unimpeded. The exact speed of light in a vacuum. And this is one of the most incredible things about light, that it's a wave that travels through a vacuum. Its medium is time-space, whereas sound needs a medium in order to travel. Light does not. Its medium is time-space. So what happens? Well, Einstein saw the world through a lens of mathematics. Mathematics that you and I will never grasp. But this was his genius. And he saw that if you approach the speed of light, something has to give way. Light sets the speed limit of the universe, and it never changes. So as an object approached the speed of light, let's say 95% the speed of light, what has to give? If the speed limit can't give, then something has to. And what gives is time and matter itself. It has to be kind of bent. And a fellow named Lorentz created the Lorentz formula, by which the effects that Einstein predicted could be calculated. And Einstein said that as you approach the speed of light, any object that approached the speed of light, the matter would be compressed, would be flattened. I think the word for an artist would be foreshortened. And time, relative to that object, slows down. So at 95% the speed of light, the Lorentz formula predicts that the object would be flattened by a factor of 3.2, and time would slow down for that object, relative to that object, by a factor of 3.2. And of course, this was all theoretical, and people said, it couldn't be true, and now, but guess what? We proved it, and it was actually not simply done, but it was proved using the CERN Large Hadron Collider, where it is possible to speed particles up to that range of speed, to 95% the speed of light. So what they did was they took a muon, and a muon has a very, very short lifespan. Microseconds. 2.2 microseconds. A muon is similar to an electron, only with mass. And the muon was sped up to 95% the speed of light. And then they measured its lifespan. And guess what? It was lengthened by a factor of 3.2, just as Lorentz's formula and Einstein had predicted it would. Now, you can't see a muon, but you would have to just also guess, we'll just give them this one, that it was probably flattened by a factor of 3.2 as well. And you say, well, if we can get things going that fast, we can get things going to the speed of light. Well, Einstein's special theory of relativity also states that to achieve the speed of light for any object, any matter to achieve the speed of light would require infinite energy. And the last time we checked, we do not possess infinite energy. It is one of those scales that rises up, and then it gets steeper and steeper and steeper until it's going straight up. So at about 98% the speed of light, it is vertical. And it will never, ever intersect with the speed of light. It will require infinite force and power and we don't have it. So according to this same theory, brought to us by Einstein, we will never, ever travel at the speed of light. And if we did, strange things happen. Time really begins to slow down as you get very close to the speed of light. And now we know this is true. We have hard evidence that this is true. So it's outside of now the realm of theory and into the realm of provable fact. And of course, in the future, we will dial that in even better and more accurately. So, what about those photons that are traveling from the center of the Milky Way galaxy to us, that take, relative to us, 40,000 years? What if we could see from the perspective of one of those photons? What would that journey be like if you were a photon? And this is the most amazing thing of all, I think. From the perspective of that photon, it arrives at Earth at exactly the same moment that it leaves the surface of its sun at the center of the Milky Way galaxy. For the photon, there is no time. It operates outside of that fabric of time and space. So why is this important? It is important because Abdu'l-Baha stated that whatsoever objects appear in the world of existence are the outer pictures of the heavenly world. So the importance of this fact that light operates outside of the rules that govern us, the importance of the fact that to the photon, it leaves the center of the Milky Way galaxy and arrives at Earth at the same moment, the importance of understanding that to the photon, from its perspective, time is collapsed, that it operates outside of time, tells us a little bit about our relationship with our Creator, and more particularly and more practically from our perspective with the manifestations of God. And both Abdu'l-Baha and Baha'u'llah used the analogy of our sun and planet Earth to describe that relationship. They said that the sun is like the manifestation of God, like the sons of truth, and that Earth is like the realm, the spiritual realm in which man resides, the reality of man resides, and that it is a nourishing relationship, and that in the same way that the sun causes life to thrive on Earth, so does the manifestation cause life, spiritual life, to thrive in the world of human existence. However, to us, that sun is far, far distant, impossibly far away, unachievable. We cannot approach the sun. We would be destroyed. We can't approach the manifestation. Our relationship is set. And this distance between us exists. And the distance between us and our Creator is infinitely beyond that. However, to the light that emanates from the Creator, to those, whatever those packets of energy are that emanate from the Creator to the world of man. Understanding, capacity, love. To those rays, there is no distance. And just as the photons from our sun arrive at Earth at the same moment that they leave the sun, this describes a perfect, a deep intimacy between the life-giving photons from the sun and Earth. And therefore it describes, by proxy, this is a picture of the intimacy that exists between the manifestation of God and man, closer to us than our life's vein. Now, there's much, much more that we could talk about with light, but I'm going to leave it at that. And I'm going to post in the chat a series of questions and challenges and so on that we'll go through in the open forum segment. And hopefully we will all learn from one another's perspective on this in our consultation and exploration and learning. Thank you for your kind attention. I used to wish that I was older. Now I wish that I was young. Looking back over my shoulder, my precious moments in the sun. Looking back, battles lost, battles won. Looking back, the crooked roads I have run.